When relocating an electrical service, ensuring proper grounding is crucial for safety and code compliance. This involves maintaining a continuous grounding path from the service entrance to all equipment that requires grounding, including the water bonding wire. The water bonding wire connects the grounding electrode system, such as a water pipe or ground rod, to the building's grounding system. When moving the service entrance, several steps are necessary. Firstly, you might need to install a new grounding electrode if the existing one is not accessible or suitable for the new location. Secondly, connect the new grounding electrode to the existing grounding electrode system to ensure a unified grounding network. Thirdly, you need to modify the existing grounding system to maintain a continuous grounding path for the ground wire. In a scenario where you're running a 4-wire SER cable from the disconnect to the panel, this cable includes a green or bare ground wire. This ground wire needs to be connected to the existing grounding system in the panel, explicitly including the water bond. Here's a detailed procedure to follow. Firstly, turn off the main breaker and completely disconnect the power to the panel to ensure your safety. Secondly, remove the existing panel cover to gain access to the internal wiring and components. Thirdly, carefully locate the grounding bar within the panel, where all the ground wires are connected. Fourthly, identify and intercept the ground wire for the water bond where it connects to the grounding bar. Fifthly, extend this ground wire using an appropriate splice connector to create a new wire that will run back to the disconnect. Sixthly, connect the other end of this new water bond wire to the grounding terminal on the disconnect. Seventhly, double-check all connections to ensure they are secure and properly tightened. Eighthly, carefully reinstall the panel cover, making sure all wires are neatly organized and out of the way. Ninthly, turn on the main breaker and verify that all circuits are functioning correctly. Some important notes to keep in mind are: firstly, the water bond wire should be of the same size or larger than the neutral wire in the feeder cable to ensure adequate grounding capacity. Secondly, always use appropriate connectors and devices specifically designed for splices and connections in electrical systems. Thirdly, carefully follow all applicable electrical codes and manufacturer's instructions to ensure safe and compliant installation. When dealing with electrical work, safety should always be the top priority. Before starting any work, always turn off the power at the main breaker to avoid electrical shock. Double-check that the power is off by using a non-contact voltage tester to verify that no live voltage is present. Wear appropriate personal protective equipment, including safety glasses and insulated gloves to protect yourself from potential hazards. If you are not comfortable or familiar with electrical work, it is always best to hire a qualified electrician to perform the installation. Working with electricity can be dangerous, and it's important to have the necessary skills and knowledge to do the job safely. When selecting materials, use only high-quality, code-approved components and connectors. Ensure that all wires are properly sized for the intended load and that all connections are secure and tight. Use appropriate tools for the job, such as wire strippers, crimpers, and screwdrivers, to ensure that all connections are made properly. Before energizing the circuit, double-check all wiring and connections to make sure everything is correct. Look for any loose wires, exposed conductors, or other potential hazards. If you find any problems, correct them before turning the power back on. Once the power is restored, test all circuits to make sure they are functioning properly. Use a multimeter to measure voltage and current to verify that everything is within the expected range. If you experience any problems, such as trip breakers or malfunctioning devices, turn off the power and troubleshoot the issue. Always follow a systematic approach to troubleshooting electrical problems, starting with the simplest possible cause and working your way up to more complex issues. If you are unable to resolve the problem yourself, consult with a qualified electrician. The grounding system is a critical part of any electrical installation, and it's important to understand how it works and why it's important. The purpose of the grounding system is to provide a low impedance path for fault current to flow back to the source, which helps to trip the breaker or fuse and to energize the circuit. This helps to prevent electrical shock and fire hazards. The grounding system consists of several components, including the grounding electrode, the grounding conductor, and the equipment grounding conductor. The grounding electrode is typically a metal rod or pipe that is driven into the ground, and it serves as the connection point between the electrical system and the earth. The grounding conductor is a wire that connects the grounding electrode to the service entrance, and it provides a path for fault current to flow back to the source. The equipment grounding conductor is a wire that connects the metal enclosures of electrical equipment to the grounding system, and it helps to prevent electrical shock if there is a fault in the equipment. In addition to the grounding system, the bonding system is also important for electrical safety. The bonding system is a network of conductors that connects all metal parts of the electrical system together, including pipes, ducts, and structural steel. This helps to create a low impedance path for fault current to flow back to the source, which helps to trip the breaker or fuse and to energize the circuit. The bonding system also helps to reduce the risk of electrical shock by ensuring that all metal parts of the electrical system are at the same potential. When relocating an electrical service, it's important to ensure that both the grounding system and the bonding system are properly installed and maintained. This will help to ensure that the electrical system is safe and reliable. If you have any questions or concerns about electrical safety, consult with a qualified electrician. Remember, electricity is a powerful force, and it's important to treat it with respect. By following these guidelines, you can help to ensure that your electrical system is safe and reliable. The National Electrical Code, or NEC, provides detailed requirements for grounding and bonding electrical systems. It is important to consult the latest version of the NEC to ensure that your installation complies with all applicable codes and regulations. The NEC Article 250 covers grounding and bonding requirements in detail. This article specifies the requirements for grounding electrodes, grounding conductors, equipment grounding conductors, and bonding conductors. It also covers the requirements for grounding different types of electrical systems, such as alternating current systems, direct current systems, and separately derived systems. The NEC Table 250.122 provides guidance on the minimum size of equipment grounding conductors for various overcurrent device ratings. It is important to select the correct size of equipment grounding conductor to ensure that it can safely carry fault current back to the source. The NEC also provides requirements for bonding metal water piping systems to the electrical grounding system. This is important to prevent electrical shock hazards if there is a fault in the electrical system. The NEC requires that metal water piping systems be bonded to the electrical grounding system at the service entrance and at any point where the water piping system is likely to become energized. In addition to the NEC, local electrical codes may also have specific requirements for grounding and bonding. It is important to consult with your local electrical inspector to ensure that your installation complies with all applicable codes and regulations. Grounding and bonding are essential for electrical safety, and it's important to understand the requirements of the NEC and local electrical codes. By following these guidelines, you can help to ensure that your electrical system is safe and reliable. In summary, when relocating an electrical service and dealing with the water bond, carefully consider the grounding and bonding requirements outlined in the NEC and local electrical codes. Proper grounding and bonding are critical for protecting people and property from electrical hazards. It is always recommended to consult with a qualified electrician to ensure that your electrical installation is safe, compliant, and reliable. By following these guidelines and seeking professional assistance when needed, you can create a safe and efficient electrical system for your home or business. Remember to always prioritize safety and adhere to the regulations set forth by the electrical codes. A properly grounded and bonded electrical system provides the essential protection against electrical shock and fire hazards, ensuring the well-being of everyone using the electrical system. The information provided is for general guidance only and does not constitute professional electrical advice. Always consult with a licensed electrician for specific advice related to your electrical project. The National Electrical Code, or NEC, is updated every 3 years, so it is essential to consult the latest version to ensure your work complies with the most current regulations. Proper grounding and bonding are vital components of a safe and efficient electrical system. They protect against electrical shock and fire hazards. When you relocate an electrical service, ensure a continuous grounding path from the service entrance to all grounded equipment. This includes the water bonding wire, which connects the grounding electrode system to the structure's grounding system. Install a new grounding electrode if needed, connecting it to the existing system. When using a 4-wire SCR cable from the disconnect to the panel, connect the green or bare ground wire to the existing grounding system, incorporating the water bond. Here is the recommended procedure. Firstly, turn off the main breaker to disconnect power to the panel completely. Secondly, remove the panel cover to access the grounding bar. Thirdly, intercept the water bond's ground wire at the grounding bar. Fourthly, extend this wire with a splice connector to run back to the disconnect. Fifthly, connect the new water bond wire to the grounding terminal on the disconnect. Sixthly, reinstall the panel cover and turn the main breaker back on. Key reminders are: firstly, the water bond wire should match or exceed the neutral wire size in the feeder cable. Secondly, use suitable connectors for splices and connections. Thirdly, always comply with all electrical codes and manufacturer's instructions. Always prioritize safety when working with electricity. Turn off the power at the main breaker and verify it's off with a non-contact voltage tester. Use safety glasses and insulated gloves. If you're not comfortable with electrical work, hire a qualified electrician. Select high-quality, code-approved materials and ensure proper wire sizing and secure connections. Utilize appropriate tools for the job and double-check all wiring and connections before energizing the circuit. After restoring power, test circuits with a multimeter. The grounding system provides a low impedance path for fault current, tripping the breaker and preventing electrical shock and fire. It includes the grounding electrode, grounding conductor, and equipment grounding conductor. The bonding system connects all metal parts to create a low impedance path for fault current, reducing electrical shock risk. Ensure proper grounding and bonding when relocating an electrical service for safety and reliability. Always consult a qualified electrician for any concerns. Follow the NEC guidelines for grounding and bonding requirements in Article 250. Table 250.122 offers guidance on equipment grounding conductor sizing. Bond metal water piping systems to the electrical grounding system at the service entrance and any point where they might become energized. Consult local electrical codes in addition to the NEC. Prioritize safety, seek professional advice, and adhere to regulations for a secure and efficient electrical system. These measures offer essential protection against electrical hazards, ensuring the safety of all users. This information is for general guidance, not professional advice. Always consult a licensed electrician for specific advice. The NEC is updated every 3 years. Stay current with regulations. Grounding and bonding are vital for electrical system safety, protecting against shock and fire. For your specific project, consult a qualified electrician.